Okay, so now we moved our way up to fourth order equations, and the good news is they're handled just like a third order equation. There's really nothing more to do except just build one more derivative from before. So once again, we know our y of t is e to the rt, and we take the first derivative, we have an r e to the rt. The second derivative is r squared e to the rt. A third derivative is r cubed e to the rt. And yes, now a fourth derivative, denoted with this little 4 in parentheses, of t is going to be r to the fourth power e to the rt. We once again substitute all this in, and we end up with now an r to the fourth plus a 13r squared plus a 36 is equal to 0. And this is where your standard graphing calculators, your TI-83s and 84s, aren't going to help us at all, because we actually have a polynomial that when you graph it, you're not going to see any real zeros whatsoever. The graph is going to be something kind of like a wiggly W shape, and you'll notice that it does not ever go far enough down to touch the x-axis. So all 4 zeros are going to be complex, but we still need to find them. And there are programs out there that can actually find these for us, but we need to actually show the algebra and do the work so we can apply it to other problems that the technology fails to work with. So let's go through and factor it. This will factor nicely as an r squared plus 4 and an r squared plus 9 is equal to 0. And then from there, we can now set each one equal to 0. So r squared is equal to negative 4. R squared is equal to negative 9. It's taking square roots. We get an r equal to plus or minus 2i and an r equal to plus or minus 3i. Now, if we think back to before, there's no real part this time around. It's just 0. So we're not going to have any exponential parts to our solution. They're going to be just sines and cosines. So this first value of r is going to give us a sine and cosine for 2t. The second value of r is going to give us a sine and cosine for 3t. So that's going to give us our 4 terms that we need. So our y of t is going to have a c1 cosine of 2t and a c2 sine of 2t, a c3 cosine of 3t, and now a fourth arbitrary constant, c4, sine of 3t. So those 4 terms will build our general solution. And you could check for linear independence by going through and finding a 4x4 Wronskian and showing that it's not equal to 0. And you could also go ahead and verify this solution by taking the first, second, third, and yet fourth derivatives, substituting them all in, and getting 0 for your check.